Hey everyone, I'm Alan from Filecoin Green. Thanks for coming and watching on YouTube if you're streaming what we're doing here. Welcome to the February Filecoin Green Meetup. If you are in Zoom and you want to introduce yourself in the chat and tell us where you are, optionally, go for it. So we have a really awesome, really packed agenda today. So first, Orion from the Filecoin Green team is going to talk about the Sustainable Blockchain Summit Hackathon, which just kicked off yesterday, and all the really exciting activity going on there and stuff people are building and ways to get involved if you're interested in hacking on any of the tools from Filecoin Green or Hedera or from Climate Collective and Hyphen. Then we have Elazavan and Akshay, who are going to be talking about Project Ostrom, which is a Filecoin Green and Filecoin Foundation grant recipient, and are doing some really neat work looking at the value of environmental assets. If anyone is familiar, Elinor Ostrom is a Nobel Prize winning economist who did a lot of work on the commons, right? So this ties into the huge amount of energy, right, in Web3 and especially in our corners of Web3, looking at how we fund public goods, right? So stick around for that. Then I'm going to be talking some about CO2.storage and what the underlying sort of data structures are for CO2.storage and what the architecture looks like. I also want to say before we kick stuff off, please come to the Sustainable Blockchain Summit, which is going to be in Boston in the middle of April, so a little under 2 months away. This is live at sbs.tech right now. If you want to come and look at the sort of things we're going to be talking about, what we're going to be addressing. If you want to speak, please hit this apply to speak button and tell us what you want to speak about and who you are. There's also this hack button goes to the hackathon that we are about to be talking about right now. So Ori, take it away.
Hi, everyone. I'm just going to share my screen quickly. And yes. So we, as Alan mentioned, have kicked off our Sustainable Blockchain Hackathon, and we are running it in partnership with Climate Collective, Hyphen, and HBAR. And this hackathon is really bringing together those sustainability enthusiasts, students, Web3 developers who are interested in the intersection of refi and Web3. So this is, you can get these slides at tinyurl.com/SBS Boston Hackathon Kickoff. And then you'll be able to join the Discord, the hackathon website, which is sbsboston.devpost.com, and then also the SBS Tech website that Alan had shared earlier. This is the team. And so this hackathon is actually a two-stage approach that we are going to have an ideation phase and a prototype phase. So for the next 2 weeks, we really encourage everyone who is interested in sustainability, who is interested in Web3. You may not have a strong Web3 background, you may not have a strong sustainability background, but we really encourage you to come to the workshops that we're hosting, come to the matchmaking sessions, meet people that you could potentially build upon who may have some strengths that you may not have. And then during the prototype phase, which is taking place mostly in March, you can then build upon your solutions that you have come up with in your team. And then also our sponsor workshops will also host workshops about their technology. And then we will have the hackathon finale at SBS Boston, April 13th. So anybody who participates is invited to come to the hackathon. And this is just what the website should look like for you. When you get on the website, you can find teammates, you can find Discord, you can find all sorts of documentation. And then if you need any resources, office hours, need to know about IPFS, Filecoin, Filecoin Green, you can always look under the resources tab. And then the updates is where I will fill you in, give you reminders about the workshops that are happening, update it with recordings that are happening, or if there's anything else you may need. Then if you have any questions that you want to ask to the general audience, you can always post in discussion so everybody who's participating in the hackathon can see your questions, but you can also email us and you can find that on the website. And so if you have any questions about the hackathon, or you may not know what you want to hack on, if you have any ideas, I also encourage you to come to our workshop tomorrow at 10 a.m. or is it 9 a.m. UTC time? I will post all of these links in the chat as well for you to see. So yeah, thank you.
Awesome. Yeah. And like Ori just said, we wanted to underscore, if you are deep in sustainability, if you're a developer, sorry, if you're deep in Web3 as a developer, or if you're deep in sustainability, right, you may not know the other one very well. We really want people who have a wide range of experiences and expertise and interests to sign up. And that's why we have this ideation phase at the beginning, is that, you know, we're really looking to just help people meet each other and talk about the sort of projects they want to build and what they want to hack on, and hopefully come up with some really cool ideas. So like Rory said, you know, please check it out. Feel free to, there are office hours links if you want to sign up with to talk to some of our team members about ideas that you have. And really looking forward to the hackathon. I think there's 157 people signed up now. So we're getting the word out, which is great. And yeah, if anyone has questions, feel free to drop them in the chat. But if no one does, we move on to Project Ostrom and the awesome work that you guys are doing.
Awesome. Thank you so much, Alan. Thanks, guys, for inviting us. I'm just going to share my screen, if that's okay. All right. I hope everyone can see the screen.
Yep.
Awesome. So I'm Akshay. And Elzafan is also here. Elza, feel free to just jump in whenever I'm droning on. You can just cut me off. We're both part of a team which is building Ostrom. Ostrom is a Filecoin grant recipient. We're trying to build holistic natural capital valuation methods. And I'm going to take you through the project, and feel free to jump in whenever and ask questions. So at its core, Ostrom is a service-based natural capital valuation methodology. It's focused on understanding what ecosystem services are provided, what sort of uses an ecosystem provides for, and how we can take those forward and value them better. So before I come to the core idea and the core work, sort of the methodology that we're developing, this little diagram that you see here is a big part of the essence behind developing this idea, which we call the climate action trilemma in the global south. And the idea behind it is that there is socioeconomic development, financing for climate action, and the speed of action. And much like sort of the blockchain trilemma, the climate action trilemma is also similarly structured, that you can solve for two at the cost of the third. So you can dedicate a lot of financing for climate projects, and you can have immense, a really fast speed of action, and the cost will be on the other socioeconomic development work that is happening in the country or in the region. And the only way we see forward in the global south for climate projects to move to be able to become a valid development methodology is if you're able to actually capture nature's true value. So typically we think of climate projects in this little beautiful perfect cycle, where there is a climate project, generates credits, businesses, industry, whoever buys it, there's a certain credit value that goes back to the climate project, and the cycle goes on and on forever. In reality, it's kind of like this, where there is a climate project, we calculate some amount of the value that it generates in the form of carbon credits and co-benefits, or whatever we call them. And there is a whole bunch of uncalculated value. We never know what sort of value the climate, this particular project is providing in terms of ecosystem services. We don't know what it's providing in terms of biodiversity, in terms of the uses it provides for, and things like that. Credits get generated, and then a bunch of them get sold. Some of them do not, and the ones which do not are continuously degrading, because as farther away you get from a credits generation date, the less valuable it is. in the overall system. And eventually there are other commissions and intermediary costs, methodology costs, and things like that. And a portion of that comes back to the climate project. So there's these leakages that happen across the process. We wanted to solve for just the leakages and not for the entire cycle. Because if you can capture what is happening in the leakages, you're able to build a nice cycle, make it work. So we're trying to develop and test methodologies that value nature holistically right now. We'd like to be able to experiment with alternative avenues where these methodologies can be utilized, and the credits generated from these methodologies can be sort of put to other users. And hopefully there are new marketplaces that come up by the time we're done with this entire process that can create avenues for their utilization. Sorry, 1 second. I went a step back. Okay. So there's a little bit of restructuring of how we approach natural capital projects that we might need to do if we want to sort of stick to this rebuild this cycle. Ours is structured around disaggregating natural capital value. We want to take each asset, disaggregate it into its constituent units. And I'll explain what that is as we go forward. And there are methods available to measure discrete units of these. And in a way, what we're doing is basically bundling several different methods together, seeing how they fit, seeing what sort of overlaps exist, and building this meta methodology that combines multiple sort of pieces. So as an example, let's consider this ecosystem asset. This ecosystem asset provides carbon sequestration, air filtration, whatever, all this entire sort of slew of services. The ones highlighted are the ones we actually end up valuing or measuring. We measure carbon sequestration, we measure nitrogen retention sometimes in some methodologies that are VCM methodologies, but otherwise the rest is just not accounted for. If we do want to account for them, the first piece would be just splitting these up and seeing what each of these methodologies do. This is an example that we've taken from our current work, which I'll come to also later, but there is a series of ecosystem services that this particular asset provides. There are particular measurement methods available to measure these services. There are specific methodology valuation types that are available for them. And there are units in which this gets output. Eventually, at where we want to arrive at is a place where we can have uniform output through a methodology that condenses all of these into one single unit. And of course, there will always be multiple measurement methods involved because you can never measure this thing in one sort of single device. So the way we're doing it is by working with a site in Nairobi, where we're sort of testing this and implementing it simultaneously with a community-based organization in Nairobi called the KECC. They've been conserving and regenerating this asset for the past roughly 10 years. The KECC stands for the Kamukunji Environmental Conservation Champions. They're a community-based organization. They're located in this neighborhood called Kamukunji. Elsa, do you want to jump in and give a little bit of background about KECC and about the site?
Yeah, sure thing. Yeah, so KECC is a community-based organization that is actually a conglomerate of smaller community groups from the Kamukunji area. The Kamukunji area is the low-income area of Nairobi. So these communities come together and try and really empower themselves at the grassroots level. So, for example, KECC took the charge of repairing, not really repairing, but rehabilitating the area that is now Kamukunji Park, since before it had slowly turned into a garbage disposal site. So over time, they've been able to get out the garbage and plant trees and create this park atmosphere that is really enjoyed by the greater community. So that has been happening for a while, but really they decided to formalize their activities during the Corona period, when now even the challenges of the community themselves became compounded. So they had to really formalize their activities, and that they really started by participating in a competition known as Changing Faces, and they were able to go through that and get some training. And over time now, over the 2 years that they have really focused their activities, this is what they have come up with so far. So as a community, I think they're really engaging with their assets and trying to really restore whatever was lost. So it's a great community, I think, that really wants to engage with nature itself and their ecosystem. Yeah.
Awesome. Thanks. Like Elsa said, the site looks like this. It's 2 parcels of land split by a small street in the middle. Altogether, it's about 10 acres, and the Nairobi River cuts through in the middle. It's a strange condition in terms of what happens around it, and we'll sort of start seeing that as we move forward. And I'll also sort of start peppering in the way we're measuring things now as we go forward. So broadly, you can sort of classify the site into three distinct zones. There's the river's edge, which is absolutely this real dense forest-like region. The river, however, is in pretty bad shape. There's a lot of degradation that has happened, and you'll see it in the images as they come later. There's this central open space sort of situation, which was in the earlier image that you saw. It's somewhat like this, where people will come and lie down under trees. They will, there's a small little farm. They have a bunch of flowers and plants and things like that. And then there is the street's edge, which is a little bit more amorphous. It doesn't have very specific form. It kind of changes from being a somewhat informal edge, which is unwilded, to, in certain cases, a very dense sort of vegetated area. So we started off by this sort of doing this mapping activity on site to understand where activities happen and what sort of activities they are, what sort of use patterns exist. And the central open space becomes this sort of recreational area. There's a huge, wide array of recreational activities that happen there. And there is a curious sort of washing activity that happens on site. Elsa can provide more background into it. Elsa, do you want to go?
Okay, so in terms of washing, maybe we quickly scanned through that, but really on the other side of the river is what we call Gikomba Market. So Gikomba Market is the largest open air market in Eastern Central Africa. And it's really involved in the business of second-hand cloth. That's what is really sold there. So part of the washing activities really involves the cleaning of these products before they are taken by street vendors for further resale in other areas of Nairobi. So there's a watering point here that is used by these vendors to really clean their clothes within the park. But then also towards the river, we have just cleaning activities, especially of shoes, using water that is collected from the river and then deposited back to the river. Yeah.
Thanks, Elsa. And there's also events and gatherings, social sort of festival kind of situations that happen on site. And there's, of course, this small urban farm that you saw the image of earlier. So we started breaking this down, see what each use is, what the type of use is, what the impact scope of that use is, and what sort of valuation that use can be put to. So for example, recreation, it's a direct use. You're not consuming any of the resources on site to use it. Therefore, it's non-consumptive. People who sort of use it for recreation are 30 minutes in the walking radius of either they live there or they work there. And the valuation methodology typically for recreational users is something called contingent valuation. It's more like colloquially, the word that is used for it is called a willingness to pay model, where you create surveys and questions that you ask people who are using the asset to tease out a certain value of that particular use from them through conversation. There's another method which is called travel cost substitution, which is to say how far you travel to, how much time you spend to travel to the site, and you substitute that as a cost that you've paid to visit that particular location. These are, of course, sort of useless unless they are statistically valid sample sizes. And at statistically valid sample sizes, they tend to provide really almost ideal results sometimes. They're employed by park systems very often in the United States. I'm not sure of how popular they are in Europe and other places. So habitat grids. This is now we need to build a relationship between the kind of habitat that the site has and the kind of use the site is put to. So we kind of divide the site into this abstract grid of 10 meter by 10 meter site segments and understand what happens within each site segment. So let's assume that this is a site segment. It has small plants, there's soil, grass, dense bushes, there's a bunch of trees. And we record this in this format, which is called a domain value table, where you categorize the spatial cover of particular vegetation structures and how much area they occupy within that 10 meter by 10 meter square that you have. So high trees, which are trees taller than 10 meters, if they cover less than 4% of the site, but there are lots of individuals within that 10%, that 10 by 10 square, they get a score of 3. And you build this entire table for each of the grid pieces on site. And then you correlate that with the kind of uses that particular grid piece is put to. It helps you understand what kind of vegetation structures give rise to what kind of uses, which then reflects back to the survey questions where people value assets specifically, and you're able to understand why value is associated to particular assets. So to do all this, there is this massive bunch of data that we need to collect. You can see pictures of Elzafan on site. He just did this last week. There's around 600 trees, around 300 other plants, river samples that were taken at 10 meter intervals, and other critical data points that we collected. We worked with a group of 12 volunteers from the KECC, and we spent, I think, Elsa, this took 3 days on site, right? Along with sort of all the prep work, it took us a little bit more than that. But I was talking about this earlier, and you can see the kind of degradation the river has gone into. It's become almost a narrow channel of water right now. I do not have another image, but at certain points, it's actually flourishing. So the variation happens very quickly. So this is where we are. We've identified ecosystem value types that we want to track. We've built an inventory. We're building out baseline. Another thing we're doing right now is that we're getting sensors ready for other ecosystem services that we want to value. If I go back, just give me a second. Yeah. There are certain pieces here that even we are not sure what the ideal method of measuring them would be. For example, let's say biodiversity. There's no animal biodiversity on site. There's only bird biodiversity. There is a contingent valuation method that we can use for doing this, but we want to try out an audio AI method, and we think that might provide us data that we can then convert into evaluation. So we're not really sure what the method will be, but we're going to sort of utilize it first, collect the data, and then see how we can utilize it. I'm just going to go back. All right. So up next, we're going to start gathering data from the baseline and start converting those data sets, studying them to convert them into valuations. And then understand how recurring valuation can be set up, how we can see the impacts of regeneration over time. Where do you go next? I think valuation is the first step. It opens doors for other means of utilization. An easy example is like there is a possibility to create eco-credit classes, right? There is a possibility to tokenize them. There is a possibility to create communities to have their own DAOs that steward land and things like that. We're not really thinking about that piece yet. We're really focused on figuring this piece out first and building it to perfection. Very quickly, before I wrap up and open for questions, I'm just going to share some of the other stuff that we're doing. We're working on locating more sites. So we're working with Refi India, which is a group of Refi projects in India, on a hackathon and festival in Gokarna that's going to happen March 22 to 26. really, our intent there is Gokarna is this beach town which has it has a key shaped outset into the river, which means that at some point it used to be a mangrove and it is not anymore. And we want to see possibilities where we can apply regeneration processes and hopefully get in touch with some of the communities that are working on. We're also always we're really interested in seeing where else these methodologies can be applied, because we're really building it for a site, but it's going to be adaptable and it's going to continue into different pieces. So if you are interested, reach out. If you know of community groups that are stewarding ecosystem assets, please do let us know. We'd love to work with them and support them in any way we can. We're thinking about it. We haven't really figured out, but we're going to be doing a Gitcoin and Giveth round very soon. So if you please look out for us if you're doing that. And lastly, this is very recent and we've just started working on it, but we're collaborating with Public Space Network Nairobi to help them implement this and regenerate a 24-kilometer stretch of the Nairobi River and its banks. So this our information is up here. Elsa has also shared them. Elsa and Alan have also shared them on the chat. And feel free to reach out if you have any questions, are interested, just want to chat about this stuff. The entire team is very nerdy about this stuff. So we're all very happy to discuss it day and night. Thank you so much. And if you have any questions, just shoot.
Amazing. Thank you so much, Akshay and Elzafan.
Thanks.
There was a question from the YouTube chat. Bala Baskar wanted to ask if SDG is also considered. So how are sustainable development goals from the UN, right, which look at a bunch of different dimensions to environmental problems and apply sort of a similar framework? What's the relationship between SDGs and your work?
So at the moment, we're really focused on understanding what exists. So we're not really considering, the SDGs are really goals for towards what to create, whereas we're really looking at what exists. I think the SDGs will start folding into the process when we start developing a plan for regeneration. We just say, now we have value. Let us assume that we have a baseline value of $10 for a tree. This is just really stupid, but I'm just saying it. $10 for a tree. And we figure out that the best way to sort of maximize the potential of this tree is by providing it X amount of open space so that it's able to grow wider, because that provides for shade and et cetera, et cetera. Then at that stage is when the SDGs will start to flow into the conversation. We need to start considering them.
Got it. That makes sense. And if people have more questions, feel free to type them in either the Zoom chat or the YouTube chat. We're looking at both of them.
Awesome.
So just so I can understand too, so the goal is you're applying all these methodologies and using that to assess, okay, what is the value of land with, different levels of different types of vegetation? What are all the different uses? Really try to capture a lot of value that's outside of that more narrow, just carbon offset plus co-benefits framework, which is sort of what's scaled so far. And you showed that really neat sort of cycle, looking at what are all the different types of value and sort of public goods value that come out of these sorts of land. So the idea then is that you're going to get a lot of data showing that these different types of land and vegetation are valuable, right? And get an idea of what the value is to these communities. And then what's the step after that, where you use that to sort of presumably drive more capital into preserving and protecting land like this?
So there is a piece here that which is now you know the value of this asset. And you also know the value of each piece of this asset. So when you're regenerating it, you can have a more targeted approach towards where you want to get to. The hope is really that communities with steward land are able to financialize their action of stewardship, and they're able to sort of get enough income to continue that process of stewardship, right? It goes back to that cycle that we were talking about here, which is that socioeconomic development, financing, and speed of action, for these to work well together in the global south, there needs to be enough of a variety of options for communities to be able to choose from when they're trying to regenerate their assets. And also, I'm not saying that communities go out and seek to regenerate assets. That's not really how it works. They're already engaged in this process for years on end. It's just that we haven't figured out a way to make it valuable for people elsewhere. If you can show value, which is why I said like the valuation is the first step. Like if you can show value, then creating a credit, putting it on the market, creating an impact certificate, things like that comes like much later. At least that's how it is in our head, yeah.
Right. Yeah. No, that totally makes sense. That like for where this is happening, right? It's something that people are doing even though they're not explicitly paid for it, because they understand that it's valuable, and like people who live in a community understand the value of the natural systems in that community, hopefully. Yeah. But if you can't like demonstrate to a decision maker, look, like this is a good thing for the city to pursue, or the country to pursue, or the province to pursue, right? If you can't like point to show them, okay, this is like the amount of value that's going to be created, then it's hard to get people to sort of decision makers, right, to invest in this kind of thing.
Yeah, it's also, it becomes almost a bargaining chip for them. Say that, the government comes in saying that we want to raise this and we want to build a nice little office building here. Can't really do that because this is much more valuable than the little sort of immediate benefit that you're looking at.
Yeah, 100%. Anyone else have questions? Feel free to put them in the chat, or if you're in the Zoom room, feel free to unmute and ask something. I was also wondering about when you had the grid where you're measuring vegetation, right? And you have like really tall trees down to like grass and like a bunch of categories in the middle there. So you said like that's a methodology that's being used for national parks in other places, and you said okay, used,
not to cut you off, not for national parks. Park systems in the US use it. So city park systems. I think the most popular one is probably Louisville. But there's a couple in Virginia that have also implemented it, and in Colorado as well.
Got it. Okay. So that's a pre-existing methodology that you're taking and saying, okay, here's like a really good way of measuring what's going on in this land. And you said like for other things you might want to measure, like biodiversity. I think you mentioned a couple other ones. Like there aren't great DMRV methodologies yet where you can just like show people like here's the set of steps to do it and like get data that's useful to plug in. But your thought is like will work.
They're not either they don't exist, or they exist for a very specific condition. So for example, we were having a discussion on air filtration yesterday as a team, and the air filtration services that are provided by an ecosystem asset are not measured for in most places. Finland, however, recently did this study where they published it and they said that they are measuring it. The reason Finland is able to do it is because they have universal healthcare, so have this enormous amount of health data about who has respiratory conditions, who doesn't, what does it cost, and all of that information. Not everyone on the planet has that. So we really need to build something that can be used in every place instead of something that can be only used by countries which have universal healthcare.
Yeah, totally. That definitely makes sense. And that's kind of the dream of DMRV, right? Is like, can we like allow people to contribute whatever types of data they have access to, right? And then use that data to back up these decisions and investments in, preserving the natural world and preserving things that are actually sort of useful and contribute to the societies that live nearby them.
Yeah.
Awesome.
Okay.
Really cool. Thank you
so much. Thank you, everyone.
Cheers. Yeah, Ostrom is amazing. Please, there are some more links in the chat. Please check out what they're doing.
Thank you.
So now I'm gonna talk a little bit about CO2.storage, which is a portal that we've been building at Filecoin Green to work with structured data to solve this problem, right? So if you are storing data associated with any of these sorts of natural goods, right? So carbon offsets might be an example of that, but tons of other types of data. A lot of times people use you'd really like to be able to use on-chain data if you're trying to work with this in a Web3 native way, in order to specify what that asset is, where it comes from, all the data associated with it, right? That like MRV data we were just talking about, or DMRV data. But the methods that currently exist that a lot of people are using are just pointing back to a legacy registry, right? So like pointing back, if you have that data in Vera or Gold Standard or one of these other registries, just pointing a URL back there, which is not a very Web3 native way to do this. And we don't have, there just aren't great tools that exist to deal with this data in a structured, principled, sort of flexible way. And so this is the question, right? Is how do I handle structured carbon offset data in a Web3 native way? And so the next layer on top of that, right? Why would we want to work with Web3 data in a way, or work with carbon offset data in a way that is native to Web3? Well, so one of the things we might want to do is transform data, this carbon offset data, from one type to another. And if you're just pointing back to URL, that data can change at that URL. You can't be super confident that the computations that you run on that data are going to be, are going to be valid. If you ran them one day, you can't be confident they're going to be valid the next day, because maybe data is going to change in that URL, right? And so this is the question: is we want to be able to answer all of these different types of questions for offsets and for other environmental assets. How do we build structured, principled ways of working with data that enable these sorts of questions to be answered, right? So given two offsets from different registries, maybe they're in different formats. Which one has longer durability? Is this compliant with a set of standards? How do individual offsets aggregate up to regional goals or national goals, right? And so one of the problems with handling this data in sort of a piecemeal, sort of Web 2 type way is that we may write code that can answer some of these questions for individual use cases, right? And if we don't have good data tracking not only what is that data, is it immutable, but also what is the type of that data, so what transformations can be run on that data, then we have to rebuild those code bases every time we want to solve a new problem. However, what we do in CO2.storage is we want these transformations to be reusable. So if you write code mapping Vera data to Gold Standard data or Toucan data to regen data, we want you to be able to reuse that code or someone else to reuse that code. So ultimately, you should be able to ask questions that can be answered by the sum total of code that people have written to operate over this data and automatically answer those questions, right? So take all of these different functions people have written and construct these data pipelines to try to answer these sorts of questions on natural asset data. And so what's the solution for this? How can we actually build tools that are going to enable this type of work? Well, so here's the idea with CO2.storage, and I'll come back to this a little bit later, is that every asset that you store in CO2.storage has an explicit data type as well as the data itself. The idea here is that data has a content address. So in Web3, we work with data using content addresses, meaning that rather than just referencing a URL, which is ultimately a location on a server, we reference data by the content of that data itself, or like a fingerprint of that data. So that means that even if the location on the server changes, anyone in the world who has the thing that you're after can give it to you if you request it, and you can verify that it's the data you wanted so that it hasn't been tampered with. So in CO2.storage, we give every data a CID, but we also give every bit of data, or every piece of data, every data set, its own type, right? Which is what we call a template in this CO2.storage asset. And so that type is really, really important, because that's what allows you to say, okay, in this view, this particular function maps from type A to type Y, say here. And because every asset explicitly has a type, we should be able to construct these transformation pipelines, allowing you to say, okay, if I have A and I need to get to Z, how do I build these pipelines that actually get me there? And so I'm going to show a little bit about CO2.storage, just show sort of how to create these types of data structures within CO2.storage to get people started using these types of tools. So if you go to CO2.storage, So you can just type this in the browser. I'll put this both in Zoom and in the YouTube view. So firstly, you can sign into CO2.storage just using your wallet, right? And so you see these buttons at the top. There's a dashboard that lets you see what are all the different assets that you're working with. There are templates. These are these data types I was talking about. And there are the actual assets, right? So those assets have this structure, right? There's data associated with them and there's a type. So if we want to make a new asset, we're going to start by making a new type. So what we can do over here is we can go to templates. And the next thing we want to check is we want to be aware of which data structure we're working in. And so we're going to start with test box over here. This is just a way of it's a place for you to create different assets. And there is a blockchain. There is no consensus mechanism on this blockchain. We're about to publish more on sort of some of the implementation details here, but the idea is that this is just a chain that grows in order to allow you to track or index the assets and templates that are associated with an account. So we're going to choose up here. We're going to choose just this test box up here. You can create a new chain here if you're interested in that. And so what we can do is then we can say, okay, let's create a new template. And so this template is just going to hold a message. So we're going to call it a message, and message from Filecoin Green. That's gonna be the description of messages in this data template. And so here we're going to type in, okay, if we have data or we have assets in the format, so right, we're on templates, in the format of message, what do they look like? And so this is just going to be like a JSON schema, if you're familiar with that. So it's going to have one attribute, we're going to say message, and we're going to define the type of that attribute, right? So we're going to say type is string. Actually, I need quotes on that. And mandatory, we're going to say a message has to have a message in it. So we're going to say mandatory is true. So we've defined this really basic just message schema, or this message data type, just saying, okay, we have a string. You need to have that string for it to conform to this data type. We're going to say create here. So now what's being done is CO2.storage just created something with this format. So you have a type or a data schema that has a bunch of different attributes or fields. The CID field points to this schema here. And so when we go up here, so this message template was just created. Actually, I'm gonna to reload this. Yeah, okay. So now there are these two content addresses here. And so this content address, this is this overall data structure. So this is this first content address that has the little cube by it. We're gonna go over here. So it's this data structure that has, it's, what we call a type data structure, has all these different attributes. It points to a data schema. And so you can go in here, you can see, okay, so this has all these different attributes. The CID field points to this data schema. This data schema, BAFY RayHaJN2, BAFY RayHaJN2, right? So this is the actual like payload in this type. And so you can also, you can go in and open that CID if you want. It should just be a JSON schema giving us this this message here, or this template here, wherever it is, this thing. If that loads, sometimes they take a while to load on this this Explorer. So the next thing we're going to do, okay, we have a template, so we're going to create an asset with that template. And so what we can do here is we can go and we can say, okay, we went to assets on top because we're going to make a new structure that looks like this. We went to select an environmental asset template. So we're going to select the template we just made, which is called message. And we're going to put a message in here. So we're going to say, hello, biosphere. And so we can fill it out. If you put more fields in that that template, you could add a lot more different types of data, including images, video, PDFs, all sorts of things, or just numbers or more string fields. And we're going to hit create here. So now what CO2.storage is doing is it's created a environmental asset, which we can go if we see, or we can see if we go to the dashboard. So this is an asset. It's based on the message template. Message template appeared here when we created it in our dashboard. So this side is the templates. This side is the assets themselves. We can go and we can see the asset has this same structure. So this here, you click on the one that has the block next to it, right? So this is this asset block. And so the structure here has the asset block, has a CID that points to the data that says hello biosphere, has a name, has a parent, all these other things. And then the template here points to that data type that we created before, that message data type. And so then the other thing that we can do here, and you can load that within CO2.storage too if you want. You can go to select environmental asset, the message should based on message template. It just says hello biosphere here. So that's that message that we added. And let's see, is this loaded? Yeah, so that was that Explorer. So it takes a bit. So the other thing that we can do if we want to say, okay, I'm the person who signed this message, right? We want to add some amount of verifiability to these templates. Another thing that we can do is we can go and say, we can click on this button, which allows us to sign assets that we created. And so this is useful, say, if we are interested in collecting DMRV data from many different sources, and we want to be able to track who contributed that DMRV data and do that in a really structured, principled way. We can say, sign this record. So something just popped up for me, a MetaMask saying sign this. So I'm going to sign that that record I created, and now it's signed. So that's cool. So let's see. So we can reload that. So there's this. So we used Ethereum signed data type version 4. And we can go and see, okay, so this is my wallet. I signed this CID. I think if we look at this CID, we should be able to load this in CO2.storage. And you have this signature message, right? So someone should be able to go and verify and say, okay, I, with this wallet signed this particular hello biosphere message. And I think we can, so just copied that CID. Yeah, here we go. So, so then in the future, right, we can send someone not just a, oh yeah, right. So we have to go over here. We can send someone not just the actual asset itself, but this whole signature message, and they can know, where this data came from. So that's a quick intro to CO2.storage and how to use it to create assets and templates. Like I said, there is some documentation on CO2.storage now. So you can go to the Filecoin Green Gitbook, which I will put in the chat here. And then you can head to the CO2.storage docs and read some about it. We're updating this pretty frequently. There's going to be more information about these data types and how to work with them up here pretty soon. So if people have questions, feel free to type them in or ask me. Someone from YouTube, Brad Guy, says, how could I contribute new environmental asset types to CO2.storage? And so what you can do here is the way you can contribute new types is by making these new templates with this structure. And if you go, if you log in and go to templates, that's the process that I just showed. So, for example, creating a message type. If you want to create a new environmental asset type, you do it by just, you can create a data schema here. And we are, happy to work with people on expanding these type definitions to come up with new types of data that you might want to incorporate. Bala Bakshar asks, can I issue my own coin or asset based on CO2 or CO2.storage? So yeah, you totally can. So the idea here is that when you have these environmental assets, this CID here, right, corresponds to this asset block. You can use that CID wherever you would normally use a CID, right? So for example, if you want to mint like an NFT or you want to mint, some other coin, you can just use the CID in the data payload and use that for things like, like traditional like ERC 721 NFTs or hypercerts, or wherever you have content address data needs. So so yeah, if people have other questions about that, I'm happy to answer them if you want to type them in the chat. And if people don't, I think we will shut down the live stream in a couple minutes, and just hang out a bit and chat in the Zoom room if people are still around.
Hey, Alan, do you mind if I, the signature for the message, is that, so right now this was for an example asset, and obviously you just demonstrated it, but when I am signing it, it obviously, can anyone sign it, or is it, what's the process? I'm sorry, I don't think I get it very clearly because I'm not very, my brain doesn't work that way, but like, how does the signature process work? Can you explain that again, please?
Yeah, 100%. So I think the paradigm shift here is that this is all for working with off-chain data, and you can put that data on chain if you want, but there's nothing about this data that's inherently on chain. Right. So there is this data structure that we use that is technically a chain just for indexing assets, but you shouldn't think of this as like a blockchain that reaches consensus about like who owns what. Right. So these assets, right, are just hanging out on IPFS. They're their own data structures that have content addresses, but they're not like, there's no like formal ownership or anything like with an NFT. They're just like, they exist out on the interplanetary file system, just hanging out in the data galaxy. And so the idea here is that you can use a wallet, right? So a private public key pair, in order to just sign the CID of this asset. Right. And so that could have different interpretations based on what this asset is. But like an example of this is, if I, say I'm measuring trees, right? And say my template looks like, here's the GPS coordinates of this tree. Here's a photo of the tree. Here's like, the circumference of the trunk of the tree or something. Then an interpretation might be, when I sign this asset, I'm just using my public key pair to create a message saying I contributed this data point, and I'm the like source of truth for this data point. That would be an example there. And then if you want to do something, if you want to use that data in some sort of like carbon offset that maybe is traded on chain, or some other type of asset, on-chain asset that has value, right? You could reference the signature message, or you could reference the CID of just that asset itself. And that would be a way for you to track what the data is, what the type of the data is, so you know how you can transform that data later, right? Maybe you want to aggregate data from many different tree measurements, and you want to make sure that they all have the same type, so you don't like crash in the middle of aggregating the data from different trees, right? So you can track all of that, all the data, the type, and then who attested to that data. So like who contributed that data point separately and really explicitly, and use that in your own project. Hopefully that helps.
No, that I get it now. Yeah. Thank you so much.
Yeah. And so, the goal of this is like, we're not trying to tell people, how to build your project, right? We're not saying like, this is the correct way to like certify ownership of these assets or like validity of these assets or whatever. We're just trying to say, okay, here is a good way of dealing with off-chain data, because for a lot of these types of assets, right, a lot of the DMRV stuff, like the file sizes are way too big to like do anything interesting on chain other than just like track ownership. We're saying, okay, here are some more tools for working with off-chain data that can allow you to build your own models for certifying that like the data came from a certain group of people or something that like actually have access to that area. There's a question from the chat from Meg. My question is about the beginning of the life of record. How is the source or origination verified or validated as authentic? Oh, yeah, exactly. Yeah, so we're just trying to say, okay, here's a set of tools for like, if you have content address data that's hanging out in the IPFS data galaxy, right? Here are some tools for doing a really sort of principled job tracking. Okay, what is the data? What's the type of the data, so we can start doing transformations on that data, and then who who contributed it. But you can interpret these messages differently based on the project that you build. Awesome. All right. Well, thank you everyone for coming. Thanks for watching on YouTube. If you're hanging out over there. So we have these meetups every month. So we'll have another one in March.